Hi, this video shows how to solve examples and several exercise problems in section 1.1. And here we focus on evaluating a function by a formula or by a graph. And you may skip this video by studying the corresponding PDF file directly. And example 3 is among the most important examples in this section. And here we have the function given by the formula or equation f of x equals 2x squared minus 3x. And we're going to find f of 2, f of 5a, and f of x plus h, and f of third root of t. So how do we understand this formula? And notice that it's kind of like copy and paste. If f is given by x, and here are two x's, and when we are evaluating f of 2, we replace x by 2 in both x locations. And then we square, multiply, and subtract, we got the value 2. Now if we are going to evaluate f of 5a, again, we replace x, okay, here's x squared 3x, and by 5a. So we got the 2 of 5a squared minus 3 of times 5a. And then we simplify the formula to get 50a squared minus 15a. And notice that 5 is inside the square, so you need to square that 5. Okay. So the last item is the most challenging, since we are looking for f of x plus h. So since x plus h occurred in the left side inside f, we replace the x in the right side by x plus h. So the first one occurred inside the square, and the second one occurred by multiplying by 3. Be careful, we need to distribute the 3 into each term and square x plus h out, and distribute 2 into each term. And that gives us 2 of x squared plus 4 of x plus h plus 2 times x h squared and minus 3x and minus 3h. Okay, so we need to distribute the negative sign into the parentheses. And we have to be very careful in this portion, because if we make a mistake by omitting one of the coefficient or negative sign, it will affect our answer for example 4. So if we can do example 3 to evaluate f of x plus h, and it should be fine for us to do example 4. And I will just skip the last term, and that will be similar to the others. So now let's look at example 4. And this time we're looking for this quotient, and this is called a difference quotient. And we have several questions in homework assignment for us to deal with this kind of formula, because later we'll realize this formula is used to define the derivatives. Okay, so in order to evaluate this formula, we will need to evaluate the first term, and that is f of x plus h. So since this time f of x is given by 2 times x minus 5 times x squared, we replace both x's by x plus h. So we get at 2 times x plus h minus 5 times x plus h squared. So again, square this out and then distribute 2 to both x and h, and then distribute negative 5 to each of these 3 terms. Okay? And then we replace this alpha plus h in the second formula by the done work. So then we plug in 2x plus 2h minus x squared, 5x squared minus 10xh minus 5h squared, and subtract. And for the second term, f of x, we just copy this formula. So, copy this formula, but notice that I put a pair of parentheses for this formula. And the reason is because here is a negative sign, subtraction. Okay, when we subtract, we need to distribute the negative sign into each term. So we have a plus plus 5x squared. Now that's very important because now we're going to delete the similar terms. Okay, so where are the similar terms? We have a 5x squared. Okay, so we have negative 5x squared. We have a positive 5x squared. So these two got canceled. Again, we have a 2x and we have a negative 2x. So these two terms canceled. So what do we have left is this 2h and negative 10xh and a minus 5h squared. So with these 3 terms, okay, and we realize the h is a common factor. So next step is to factor out h. Now it's time to cancel these h. So notice that only when h is a common factor for the numerator, we can cancel h from numerator and denominator. And also notice that the conditions given, h cannot be 0. Therefore, we can cancel that h. So the answer for this question is the formula becomes 2 minus 10x minus 5h, for h is not 0. Okay, so let's look at the next example. And that example concerned was evaluating a function on graph. So this time the function g is represented by the graph in figure 116. And we want to find g of negative 2 and g of negative 1 and g of 1. So these negative 2, negative 1, and 1 are x values. To evaluate a function through the graph, we need to draw a vertical line going through the x location. So here is negative 2. If we draw this vertical line, we are going to hit the graph at this point. So, what is the y rating of this point? Go horizontally to find y rating is 2. Therefore, g of negative 2 is 2. And at negative 1, if we draw a vertical line, okay, And we see that this line goes through, looks like 2 locations. But pay attention, only the dot count, because the circle means the line just goes through without hitting it. So the dot had the y rating 1. Therefore, g of -1 is 1. And finally, for g of 1, again, the vertical line passing x equal 1 will hit this black dot. Okay, and the y rating of this black dot is 3. So our answer for the last question is g of 1 is 3. So let's go through some exercise questions. And here comes the number 1. Okay, and we are looking for the function values at 6 locations. And we follow the same strategy as example 7. In -3, the vertical line will hit the curve at 1. Okay, y rating 1. And at -2, the curve will hit the vertical line will hit the curve at y rating 3. And at -1, okay, this time the vertical line goes through and it passes the circle first and hit the dot here. So the dot is located at the vertical reading is -1, and therefore f of -1 is -1, and f of 0 again is -1, and f of 1, since it hit the dot first at 1, so f of 1 is 1. Okay, and f of 3, the vertical line hit the curve at 0, so f of 3 is 0. Okay, and the last exercise question, we have a similar formula, f of x equal 2x squared minus 2. Okay, this is actually simpler than example 4. And first we want to find the domain of this function, and notice that for a polynomial, and it makes sense for any of the x values. So the domain is always -infinity to infinity. To evaluate the function values at different x values, we just plug in. Okay, so this is quite straightforward. For f of 5a and f of square root of a, follow example 3, and we'll look at this term first. Okay, we'll see square root of a got squared, so we can simplify it to be a. So we get answer is 2a minus 2. Now, part D is getting ready for part E. So that's my recommendation whenever we are given this formula. Okay, whenever we are given this formula, we always want to evaluate f of x plus h first. Okay, so by replacing x by x plus h, and don't forget to square it. Okay, so x plus h is inside the square. So often I will grade that this term 2x plus h got omitted. But notice that a plus b squared is a square plus 2ab plus b squared. And then we also need to distribute 2 into each term. And then we'll subtract it by 2. So here comes the f of x plus h, and this whole term being replaced in the first portion. Okay, and then subtract. Again, here are the pair of parentheses, and we copy the formula f of x and distribute the negative sign into each term. And again, we see that we get to cancel these terms. Okay, 2x squared and here is, 2x squared and minus 2x squared. Okay, and then we have negative 2 and plus 2. So what do we have left? Only two terms, and that is 4xh plus 2h squared. And now h becomes a common factor of the numerator, and pull h out, and by this time we can cancel h in numerator and denominator. And notice that since h is not 0, we got to cancel them. So the answer for question E is 4x plus 2h. Okay, that's the end of the problem solving in detail.